Good morning, Year 10s. Hello, guys. Sorry I'm slightly late. I've been having computer issues. It's so typical that at this particular time, when we're doing all of these various online learnings, it happens to be that my laptop decides to have a complete meltdown. Anyway, so we're going to be continuing on with equations. I'm sorry, I'm just trying to now get to my channel on my laptop so I can make sure that you guys can all hear me. As I said, I've been having, oh, there we go. Okay, that's all running, which is great. Got one person watching. I'll try and remember to send out links to all these various things from now on, but you guys should just be trying to, hey, Rue, thanks for coming. Thanks for coming, guys. Right, I'm just going to drop straight in because last lesson we were looking at equations and I need to finish off equations. I'm really hoping that my laptop manages to survive this without going crazy. I've done a bit of a hard reset. But let's just pick up where we left off. We were looking at equations, looking at the rules, and we will continue. So I'm going to drop into sharing screen. Share. There we go. I'm then going to try something new, which is I'm going to try and stop my camera. Because if I stop my camera, and then I don't know if I can actually remove from stream, but what I want to do is, I'll post the link to one of the classrooms. That would be really appreciated, thank you. See, it's still running my camera, and I think that is what's causing me all of my issues. I don't really have much choice, I think. I'm just going to have to do it like that. Right, I'm assuming that now means you can hear me. Can you guys hear me now at this point? Ah, there we go. Sounds bad. I'm just going to have to do it like that. Fingers crossed. I'm assuming that now means you can hear me. Yeah, I've got myself on echo. Lol. Right, okay, guys. So what I'm going to do today, I have posted on your classroom. I have posted on your classroom homework, and I'm going to go through that homework in Year 10A's lesson on Monday. I'm kind of hoping that you guys are going to attend as many of my lessons as possible. I know that I'll also go through it on your lesson on Wednesday as well, so I'll do both. But today, what we're going to do is last lesson, if we have a look at last lesson, we were picking up these rules. We looked at the rules for equations. We said that there are two main rules that we've done so far, which is swap the metal, and then we did our acid-base rules. Now what we need to do is we now need to add in a couple more. Now, again, want to reinforce, I know this is hard, and it seems like an awful lot of rules, but in reality, at GCSE, this is it's never asked heavily. It's always light in terms of the amount of actual questions on it. So we now need to look at reactions with water, with H2O, and I need to do combustion reactions. Those are my two learning objectives today. Learning objectives is know the rules for reactions with water, know the rules for combustion reactions. And at that point, combustion reactions, there are also combustion reactions. And I'm also going to say no oddities. Now, can I just point out, this one is, I'm not expecting you guys to learn these. You really don't need it for GCSE, but I'm just going to mention a few that do come up and some that are just important. So, okay, so let's quickly drop into reactions with water. I've got to try and get used to this thing again in terms of size of pen. So water reactions. I'm going to try and turn down my laptop. Water reactions. Okay, so first thing is we just, you see my screen has already begun to shake, and that's the problem. I will endeavor to continue. It's really already now at the point where it started to shake. I'm hoping I'm going to get this repaired over the weekend. The problem is with this lockdown, I've got a major issue with that. This is where I genuinely think it's the camera that's running at the top here. And I really wish that I could disable the camera, because if I could disable the camera, it probably means that it probably wouldn't be shaking like this. I'm pretty sure that that's really what's causing it. I'm not entirely sure how to go about doing that either. Edit. No, you see, it just won't let me disable the camera. Camera settings. It says it's disabled it, but it's still running it. I know it is because the light's on. I don't know whether or not I can see it somewhere else. The laptop is shaking away. Oh, well. View. Wonder whether or not I can view anything else. No, I can't. I'll just have to keep going with it and see how I get on. Okay. So I think you guys should still be able to see this. So, okay, so water reactions. So metals, this is metal with water. Metals plus water. And what we tend to get, in fact, not a double dot, is it? It's an equation, so an arrow. We're going to get the metal hydroxide. Metal hydroxide and hydrogen. So that's the rule. Try and zoom out a bit. Metal hydroxide and hydrogen. So let's look at an example. So we can do sodium. This is Eg. Sodium plus H2O, arrow. Right, guys, pause the video and have a go at completing it. Don't forget to balance. Thanks so much for coming, guys. I've got Toby, got Ben, got Nick, got Isabel, got Anna. It's great to see you all. So just pause the video and have a go. Right, here's the answer. I'm going to form sodium hydroxide. Now, I'm just going to remind you guys, we're always reminding ourselves to build these equations and these formulae. So Na plus OH1 minus, and we're going to cross them down. It's a 1 and 1, so that one, plus hydrogen, it's ending in a gen, so it's going to be in a pair. Okay, don't forget to balance. So we've got one sodium, 2 hydrogens, 3 hydrogens. That doesn't work. Common denominator is 4. So I'm going to get, sorry, common denominator technically would be 6, but I can make that into a 4 by adding a 2 at that point. That's now 4. I can now add a 2 in front of there and a 2 in front of there, and it should add up. Let's just check. We've got 2 sodiums, 4 hydrogens, 4 hydrogens, 2 oxygens, all adds up. So it does take a bit of practice. Balancing equations always does. Cool. Let's have another go. Another one. So we're now going to do, let's do calcium. Calcium metal plus water. Word equation. And then what you can do is pause the video, finish the word equation, and then convert to symbol. So that one's going to produce calcium hydroxide and hydrogen. We get this common patterns in chemistry. We don't need to worry so much, because that's why I love teaching it, because there's routines, there's patterns. I don't need to memorize everything. I learn the rules and I can apply it. Right, let's convert to symbol. So calcium metal is just Ca, and it's a solid. Plus water, H2O, it's a very rare state symbol, L. And we're going to form calcium hydroxide, right? We're going to have to build that. Ca, calcium is a +2, OH, 1-, crossing down. So we're going to get Ca open brackets 2. It's a common mistake for students just to put a 2 on the end, but then you need 2 oxygens as well. So watch out for that one, plus hydrogen gas. Now, of course, we can even add our states. Calcium hydroxide is going to be aqueous. Hydrogen is going to be a gas. And we can now balance it. 1 calcium, 1 calcium. Hydrogens 2. Oh, hydrogens 4. 2 here, 2 here. So 4 hydrogens, so double that one. Next, oxygens, 2 oxygens, 2 oxygens. It balances. Quite nice. I know it takes practice. I do. It's just one of those things that just requires these equations after equations after equations of practice. And it will get easier, I promise. The more you practice, the easier it gets. Right. Let's go for one more, shall we? Let's go for one more. Let's go for iron. Oh, question is iron. Do I want to do iron? Yeah, sure, why not? Iron metal plus water? Well, I shouldn't really do that, to be fair. It does, yeah, okay, I will do it, but it's just, you don't really need to worry about this one so much. Iron plus water, going to go to iron 3 hydroxide. And hydrogen. Convert to symbol, please. Remember, I'm now, rather than knowing the products, I'm testing on your ability to create equations and create formulae. Have a go at that one. So pause the video. Have a go. So we've got Fe plus H2O. Right, I'm going to form iron 3 hydroxide. Ions, Fe3 plus, OH 1-. Crossing down, I'm going to need 3 of the hydroxide ions. I prefer looking at that in charge. I need 3 minuses for every 3 plus. So I need 3 of the hydroxide ions. So I'm going to get Fe open brackets, OH3 plus hydrogen gas. Now we need to balance it. So we've got 1 iron, 1 iron, 1 iron. Oh, hydrogens 2. Oh, 5. That's awkward. So we need a common denominator, really, don't we? So 5 and 2 is going to be 10. That's awkward. So let's treat the element. Okay, so what we can do is, the problem that we've got here is that we've got 5 hydrogens. And that's an awkward number. What we'd prefer is an odd number, sorry, an even number rather than an odd number. So if I put a half in front of that H2, that's going to make that 2 become a 1. That means I've only got 1 of them. What that now means is I've now got 4 hydrogens. I can get that by doing this. Now, the problem with that is, now that I've balanced for the hydrogens, my oxygens no longer balance. Because my ions do, my hydrogens are now at 4, because that's half of 2. But now my oxygens are, because now what I've got is I've got 2 oxygens and 3 oxygens. Right, common denominator is 6. So I need to get everyone now to 6. So I need this guy to be a 2, and this guy needs to be a 3. Right, now I can look at the ions again. I've changed something. I've now got 2 ions. 2 ions, 2 ions. Hydrogens. I've now got 6 hydrogens here. But I've now got 6 hydrogens there and no H's coming out the other side. That's not nice, is it? So we've got 6, 3. Oh, hang on a minute. Hang on a minute. I didn't make it 6, did I? Need to make that 6. My apologies. My apologies. 2 ions, 2 ions, 6 oxygens, 6 oxygens. Sorry, my mistake. Easy to do. 6 oxygens, hydrogens, 12, 6. So I now just need a 6 there. So I put a 3 there, it should add up. There we go. So there's my balanced equation. Not an easy equation to balance, that one. Really nasty. You guys might recognize this as well from chemical tests. That there is iron 3 hydroxide. And I wonder how many of you can remember this from your chemical tests. So this one, of course, if someone would like to give me a color for it. I wonder if I can get this on a message. The problem is people would have paused the video, which means they're now out of sync. It's brown. Iron 3 hydroxide is the chemical test for iron 3 plus, which is going to be a brown precipitate. Rather nice, that. Okay, so now that we've done our metal plus water rule, we can now look at our combustion rules. So let's now look at combustion rules. I can underline this one. I'll leave that there for a minute and just put combustion rules. Combustion rules. Everybody loves combustion. Okay, so brown. Good job, Shanley. Good job, Ben. Good job, Ooming. Great job. Good job, Harris. Outstanding. So combustion rules. So we know combustion is all about burning. That's what this is. Now, to burn something, combustion is very specifically about carbon and hydrogen. Because in reality, what we realize is happening is that when something burns, it's a very specific kind of reaction. We've got products which we're used to seeing all the time. And when we see that word, we then need to apply our rules to what we're going to make. So the first thing in really that we need to write down is combustion produces. So combustion produces very specific products. Number 1, carbon dioxide. If you burn something, you're probably going to get that. CO2 as symbol. You also get water. H2O. Now, there are other products of combustion, and the other products are carbon monoxide, and carbon. Now, carbon, I'm going to put carbon monoxide as CO, and carbon is just C. These are sometimes, the last one of carbon, everyone recognizes carbon monoxide as a toxic gas, but carbon often is not recognized, and these are often called carbon particulates. And the word particulates literally means dust, otherwise known as soot. This is what happens when you have a yellow Bunsen burner flame, and when you try to heat anything on a yellow Bunsen burner flame, you cover it in black dust. That black dust, that black soot, is carbon as a solid. Now, the question is, when do we use these different products? And the answer is, it depends on the question. So, number 1, we need to just emphasize water. So, water is always made if hydrogen present. Always made if hydrogen is present. Okay, what about carbon dioxide? Carbon dioxide produced in complete combustion. Produced in complete combustion. So what about these guys? These guys go together. These guys are produced in incomplete. Now, the first question, incomplete combustion. The first question I always get at this stage is, well, how do I know when that's occurring? How am I going to know this? And it's a very straightforward answer, folks. The answer is they're going to tell you. So this actually makes things a whole lot easier. So let's look at some example questions. So question 1. Write equation. I'm going to try and make, at this point, I seem to be zooming further out, so I'm going to make my pen a bit thicker. Write equation for complete combustion of propane. Right, so so straight away we can now realize key bits in the question. Number 1, complete combustion, which means I'm instantaneously knowing my products. That tells me that I'm going to get CO2 and water. That's what it now tells me. Next thing, of course, is propane. So this now comes from your year 9 chemistry. In year 9, we were doing organic chemistry, and you guys were learning how to build organic molecules made from carbon and hydrogen. Sometimes oxygen as well, examples alcohol. But in this case, we're going back to that year 9 and being able to put it together. So we're saying propane. So straight away, we now go, this is going to be going in. So propane, C3H, double it and add 2. Right, it's a combustion reaction, which means this is the reaction with oxygen. So we've missed a rule there. Combustion products, and we've missed the fact that we need to also say that there's oxygen going in. Whenever you burn anything, the word combustion means burning. And if we're burning, we're adding oxygen. So we're going to add oxygen. This comes from our fire triangle. This is our fuel. This is oxygen. What we're now going to get is the products that were said in the equation, said in the question even, which is complete combustion tells us CO2 and water, and then we balance. So you can now pause the video and have a go at balancing those equations, or balancing that equation. So now that you guys have paused, so 3 carbons, 3 carbons, 3 carbons. I'll make that a bit clearer. 3 carbons. I've got 8 hydrogens. I need 8 hydrogens. Next, oxygens. Oh, 6, 4, total 10 oxygens. I need 10 oxygens on this side, so I add a 5. Cool. And these products are told to us because it was complete combustion. Let's go for the next one. Okay. I'm not going to take that away just for a minute. I'm going to leave that there. Question number 2. Write equation. Write equation for incomplete combustion of methane to produce a toxic gas. Right, so you realize what they're doing, which is they're telling you the product. They're telling you which one I'm getting. And in this case, we're getting carbon monoxide. We always get water as long as hydrogen is present. And methane, of course, we can build its formula. So the equation, you can now pause the video and have a go at this one. So this is going to be methane, which is CH4, plus oxygen, because we're doing combustion. And whenever you're burning anything, you need oxygen. And we're now producing CO and water. And now we just need to balance. So we get 1 carbon, 4 hydrogens, 2 hydrogens, added 2. Oxygens, oh, 1, 2. So 1, 2, I've got 3, that's awkward. Right, but the great thing is what we can do when we get that number 3, we've got a 2 here. How do you get a 2 to a 3? What do you multiply it by? You multiply it by 1.5. Now, you can't use a half in GCSE, so we're going to double the equation. So it's going to become 2, 3, 2, and 4, and that should add up. Let's check. 2 carbons, 8 hydrogens, 8 hydrogens, 6 oxygens, 2, 4, 6. We're good. Okay, next question. Question number 3. Write equation for incomplete combustion of, let's go for ethane, to produce carbon particulates. They're literally telling you what the product is. So in this case, the product, of course, is carbon as a salt, is carbon. So the products are carbon particulates. And you can pause the video, have a go at doing it. So we've got ethane. So C2H, double it and add 2, 6 plus O2. It's combustion. Yeah, you always need oxygen to burn. This is our fuel, and we always need oxygen. Right, it is incomplete. So I'm getting carbon. There's hydrogen, so I always get water. It's always nice, that's good routine. Kieran asks, if it's complete, why isn't carbon made as a product? Complete means you're oxidizing everything, Kieran. You've got to understand that. Essentially, if things like to bond to oxygen, it's actually a good thing to bind to. The reason being is the bonds are really strong. And this is a good thing. The stronger the bonds, the more something wants to be in it. And so complete combustion is you're providing excess oxygen, more than enough oxygen to ensure that everybody can bind to as much of it as you like. And that means that you're going to get carbon dioxide rather than carbon particulates. Carbon doesn't want to be on its own. It'd much prefer to be with oxygen. Wait, he said if it's incomplete. So if it's incomplete, you're going to get carbon. You're wondering why it takes, okay, you're wondering why you make water. Okay, Kieran, totally get it. So let's look at the methane as an example, because the methane is slightly easier for me to draw. Just makes it a bit easier. Ugh, struggling to give me another side. So methane looks like this. Meth is 1, of course. So we've got that. If we now show it oxygen, what you realize is during the collision, when these things collide, the first thing that's going to get hit are the hydrogens on the outside. And people often say, well, it could sneak through the gap and hit the carbon. And I'm like, no, it really can't. I can show you why that is. The reason why is because if you actually look at methane structure, methane molecule, look what it looks like. In reality, see, these aren't good diagrams. The real picture is that one. That's what it really looks like. You're going to hit the H's first without any doubts. So this is going to take the H first, and it's going to form water. And then what's going to be left behind is you're going to be left behind with carbon. That's the first thing that's going to happen. That's why you always get water as an output. Let's balance this equation. So we've got 2 carbons in, 1 carbon out, double it. 6 hydrogens in, 2 out, triple it. Oxygens, 2, oxygens, 3. How do we get 2 to 3? Multiply it by 1.5 and double the equation to get rid of the half. So that's going to become a 3, 2, 4, and 6. And I'm done. Let's check. 4, 4, 12, 12, 6, 6. That's good. Takes a bit of practice. I know equations are hard, folks. I really do. And I'm very aware of how tough they are. And I just don't need to worry too much. I will post some combustion questions now in the classroom for you guys to practice doing, going from words to symbols and recognizing that the questions always give you the product in the words that they're actually giving you, either by incomplete or complete. And it's just learning the rules. Okay. That brings us to the end of the rules that you really need at GCSE. And I just want to focus, I want to go back and have a look at some questions that I've kind of just quickly grabbed. So this is similar to the worksheet that you guys have got posted on your classroom. I posted this morning, so you guys can have a go at completing that other one for the homework, and this one maybe provide a bit of help in terms of how to go about doing it. So the first 5 questions here, they're just looking for you to be balancing the equations. So it's a relatively straightforward process. What they're looking to say is calcium solid plus nitric acid, calcium, nitrogen, and hydrogen. They've given you the equation, all the formula is there. So this is just a very simple practice of balancing. I think this one's okay for most students. Yeah, this is something we've done already in the past. So it's just counting. 2 calcium's 1, calcium's 1, hydrogens 1, 2, right, double it. Got to go small again now. Double it. Next, so there's 2 hydrogens, 2 hydrogens. Now I've changed somebody, start again. 1 calcium, 1 calcium, 2 hydrogens, 2 hydrogens. Right, and we're going to treat the nitrate as an entire entity. Rather than doing it atom by atom, let's just treat that, because that won't get broken up. So we can just say there's 2 of those. Oh, and look, 2 of those. So it balances. That was it. Nice, easy equation to start off with. Notice metal plus acid, salt and hydrogen, seeing our rule up here. Right, here's our first oddity. So people often say, hang on a sec, swap the metals. Well, there's no metal to swap here, folks. It's actually going to combine to form PCl5. And I don't want you to worry about this one too much. They're always, if they wanted you to do this, they're just going to give that to you. And what you'll notice is it's already balanced. So it's a bit of a trick, that 1, 1, 1. Right, phosphoric acid. I gave you that at the start of year 10, I think. It's an addition. It's actually an A-level acid. You don't really need it at GCSE, but it's nice to see it, though. So this is metal hydroxide. So the rule here is metal hydroxide plus acid, salt and water. Okay. So the salt is going to be sodium phosphate. So it's already given you us the formula. Given us that, you just need to balance for it. So hydrogens, 3. Hydrogens 2. Common denominator 6. There we go. Next, phosphates 2. Oh, only got 1. Double it. Cool. Right now, sodiums 1. Oh, that's tricky. 6. That's a tricky one, that. There you go. Next. Right, hydrogens, but remember the phosphates don't count because they're already done. Does everyone agree with that? So we can ignore the oxygens in that sense. 6 oxygens. Oh, that's now no longer going to add up, is it? Hang on. 6 oxygens. I need 6 oxygens. Okay. Next, so let's just check this again. It's got hydrogens. Oh, hang on a minute. I've made a mistake there. Oh, no, I've dropped something. 6. I've made a mistake there, guys. Look, hydrogens. I've got 6 there and 6 there. So 12. So I'm going to need 6 in front of that one. Sounds reasonable. 6 and 6, 12. If anybody's wondering why I'm struggling, it's because my laptop screen is shaking. I'm hopefully going to have it repaired this weekend, as I mentioned earlier. I don't think so. Will there ever be a situation where hydrogen is not present in a combustion reaction? Yes, there can be. Absolutely. You could just have carbon burning coal. That's a good question. Sorry, I've paused at the balancing equations as well, and I don't really want to. 12, by the way, do you notice 6 oxygens, it now balances. So that's actually the correct answer to that equation. I'm just going to quickly answer that question there. Is it possible to ever have a combustion reaction with no hydrogen? Yes, there is. So combustion, I'll make my pen a bit quicker, a bit fatter, sorry. Combustion, no hydrogen. So examples, carbon plus oxygen. Now, depending on whether or not it be complete or not, if that's complete, it would be CO2, and it balances. If it was incomplete, it would be CO. And you can't just get C on its own, and I'd have to balance that with a half, which means I then double the equation. There you go. So here's the complete version. Complete, here's incomplete. I am very aware, by the way, that I don't want to overrun on my lessons because I know that you guys have got other lessons to do as well. Just keeping an eye on the time. So other examples of that is sulfur, amazingly. Sulfur can also burn. Now, sulfur is actually a fascinating substance because when it burns, it can't make SO. It has to make SO2. So that's the burning of sulfur as well. And you can also get SO3, but you can't get SO3 directly from S, which is a bit of a nightmare. But it's not really a combustion. That's the combustion one for sulfur. It'll come under our oddities, and we'll see it later on after the lessons are break. Ah, you're right, it is. So those are nice. But what you realize is the hints are in the question. Like you can actually see what's going on here and how you realize that you can't get water from this. It's not going to be possible if there are no H's. Water's not just going to spontaneously appear from nowhere. You see hydrogen, you're going to get water. You see carbon, you're probably going to get CO2 if it's complete. The symbols are super helpful. This is actually partly why word equations are limited compared to symbol equations. Symbol equations give you far more detail of what you're handling. Let's go back to this one. Oh, right. So the next question number here is number 4, and it's a complete combustion. So straight away, I recognize the product. I'm getting CO2. So this is a complete combustion. I'm just going to balance it as needed. So I'm going to get 5 carbons, 12 hydrogens, 12 hydrogens, oxygens, 10, 16. Ouch. 16 divided by 2 is 8, and I'm done. Next. Oh, right. An oddity. This is what I mean by there are oddities in the world, and then you never need to worry about it. The reason being is they're not expecting you to know all of these equations. What they're going to do is simply give you the equation in its entirety and ask you to balance. Yeah, so don't ever worry about that. They could give you it in words and ask you to translate, totally reasonable, but they're not going to expect you to be able to give an equation like that at a GCSE level. It's just not expected. So this is the formation of nitric acid. So NO2, NO plus H2O goes to plus O2 goes to nitric acid. Balance it. 1 nitrogen, 1 nitrogen. Oxygens, eek. 1, 2, 3, 4. Ah, that's awkward. Let's double it to make that 6. Now the great thing is, if I double that to make it 6, well, I've got to double the ends. So double the ends there. Yeah. I just wanted, the reason people often ask, why did you double it? Because I wanted to make it an even number. 3 is just awkward. Make it even. So if I doubled it, I got it to 6. So once I've got to 6, let's now check my nitrogens. I doubled, of course, to get it back to 2. And then I'm going to put my little fan back on to try and cool my laptop down a bit. So my NO water, okay, so yeah, so my nitrogens are balanced. I've done my O's and now at 6. So let's just go back to the beginning. 2 nitrogens, 2 nitrogens, oxygens, 2, 3, 4, 5. Oh, right. I can fix that with the oxygen by adding it in as 1.5. I'm going to get an extra one. I'm going to get 5. That takes me to 6 now, doesn't it? Because that gives me 3. So now that I'm at 6, that's the oxygens are now technically balanced. Let's check my H's. 2 H's, 2 H's. So I'm actually balanced at that point, but I just want to get rid of the half. So I'm going to just double everything. 4, 2, 3, and 4. Hard equation to balance that. They get easier the more you practice. Right, the next one now, of course, is applying the rules that I've been giving you. So the first one is just a straightforward, they've given you all the words, they've said to you, they just want you to practice going from word to symbol. So that one's going to be iron solid, nice to include state symbols, plus oxygen gas. Remember, any element ending in -ene or gen is going to be diatomic. And then that's going to be producing Fe2O3. How did I build that? Iron 3+, the oxidation state is given to us here. O2-, because oxygen is always 2- unless in hydrogen peroxide. So I'm going to get Fe2O3, then balance. It's nice to say that it's a solid too. Balance it, 1 iron, 2 ions. Oxygens, 3. I can put 1.5 there to get my 3 and then double everybody. 4, 3, 2. That works. Right, now they're making the level much harder. Now they're making it a lot harder because look what they're now doing. They're now saying complete the equation. So ammonia, this is a tricky one. Now this is actually an acid and a base reaction, but this one actually is important for me to mention because this is a standout oddity which you do need at GCSE. It is required. And so in this case, we now need to transform ammonia into NH3. Sulfuric acid into H2SO4, and this is a standout one. And I also add this as almost a rule, really, because what you're going to get is ammonium sulfate. It's a really unusual one because it's an acid-base reaction, but there's only one product. It's just salt, just one salt, which is NH4 brackets 2SO4. That's hard, that. It's a standout reaction because it's very strange. You get no other byproduct. Hydrogen gas and nitrogen gas combining to form ammonia. Again, another one which you have to know for GCSE to form ammonia in words, which is NH3 and balance. Here's our acid-base rules. I've got a carbonate, metal carbonate plus acid. So there's my rule from the previous lesson. Metal carbonate plus acid gives me salt water and CO2. So first of all, sodium carbonate, Na+1, carbonate, CO3, 2-, cross and down, Na2CO3, plus hydrochloric acid, HCl, and I'm going to get sodium chloride, CO2, and water, and then balance. Oh, right. This one's an interesting one. Bromine solution. Bromine. Remember, anything ending in -ene or gen is diatomic. Plus Ki. Great one, this. Sorry, my laptop paused. And the last, swap the metal. KBr. Plus iodine and balance. Right. So I've gone through those questions there. You can pause the video. You can always rewind and pause it if I'm going a bit too quick for you guys. Since my laptop's having a meltdown, I'm gonna leave the lesson there. I have posted work on the classroom. I've posted work on the classroom. So have a go at doing those questions, and I'll go through those answers on my next webinar on Monday, and I'll probably look over them as well on Wednesday in case you missed that lesson. Right. I'll see if I can go back to here. Let's see if I can bring this back up and go. Let's go add in camera. I want to turn it on. Start cam. Way, there we go. And I'll go back to that one. Right, guys, I'm going to leave you there at that point and say have a good rest of your day. I hope it was helpful. Do review it. And as I said, there's questions on the classroom for you to have a go at. I'll post a second set, including some combustion equations for you to have a go at. Guys, have a great rest of your day. See you later.